We humans have come a long way, traveling our world in search of new lands, spreading to every corner of the globe. But the time has come to look to new destinations, to go once more into the unknown. This is the story of our journey in space. We will fly to the stars on a ship that sails on sunlight. We'll explore the most distant edges of the cosmos by taking a roller coaster ride through the very fabric of our universe. And we'll discover the machine that has charted the heavens as never before. It's the voyage of a lifetime, a voyage to our future in space.
We've always had the urge to explore. Our ancestors journeyed into the unknown to discover new lands, and now it's time to do it again. But this time, it's not a voyage between continents. This time, it's a voyage to the stars.
As our telescopes get ever more powerful, they have shown us a universe of unimaginable beauty and power. Vast clouds where new stars are born. Strange galaxies. Even tantalizing hints of new worlds. But they've also shown dangers. Disasters so huge they could destroy the Earth in seconds. Space is full of terrors and wonders. But will we ever see them for ourselves?
We have a dog.
It's less than 50 years since we took our first steps out into space. Since then, thousands of rockets carrying hundreds of people have made the 10-minute flight into orbit. Astronaut Story Musgrave is one of a new breed of space adventurers.
When you see a launch from the outside, it's a rather glorious, magnificent thing. Inside, it's the absolute opposite of that. It's 137 decibels. It's shaking. Everything is shaking. You have the solid rocket boosters that are really pounding the vehicle and all. And then you have the turbulence in the atmosphere that adds another shake, rattle, and roll. And so you're basically in a small closet here with belts and straps and helmets and gloves and parachutes, survival gear, and you got all of this. It is all over you, and at the same time you're being shook. And it can't help but pass through your mind, you just want the whole stack to hold together. You're along for the ride and you want to survive that. So it's not a joyride for me. It's what I need to go through to get into the incredible serenity and celestial dance of zero gravity.
So, Houston, we are inspired. We are ready. Let's go fix this thing.
We are becoming a race of spacefarers. It's a strange and unfamiliar world. But for the privileged few who go there, it is an experience they can never forget.
Spacewalking is much more like a dance than anything else. You choreograph every move. You choreograph every finger, every toe, every body position, and how you're going to do all of that. It's just as precise as a ballet. Going into space, it's opening night at the ballet. During a spacewalk, I love to look at my feet. You see your boots going 18,000 miles an hour, 25,000 feet per second. You see your boots going down the road. If you ever want to play Superman, that's where to do it.
We stand on the edge of space. Our most ambitious project is testament to what we have achieved. The International Space Station, Freedom. But it's surprisingly close to home. It's floating less than 400 kilometers above our heads. The furthest we've traveled into space is this. In 1969, we set foot on the moon.
That's one small step for man, one giant leap for mankind.
For the first time ever, we looked back at our home from the surface of another world.
It's amazing to think that people have actually walked up there. The trouble is, it may have been a giant leap for us, but in the vastness of space, it really was just one small step.
Although we humans haven't reached any further than the moon, our robot ambassadors are already reaching for the stars. Where we cannot go, we have sent machines.
This is the Voyager probe. Nothing we've ever created has traveled so far from Earth. It's now left our solar system on its way to the stars. Look at how far it's gone.
Voyager left Earth in 1976. It passed Jupiter, then Saturn, and now it has left all the planets far behind. After decades in space, it's 14 billion kilometers from Earth.
It's an impressive journey, until you consider this. On this scale, the nearest star to our solar system is way over there. In fact, it's over 100 kilometers away. To reach it would take Voyager another 25,000 years.
At Voyager's speed, even reaching the nearest star is an impossible journey. But perhaps there's hope. It's easy to forget that in a single person's lifetime, we've gone from this to this. And in our quest to reach the stars, some scientists believe the answer could be to go from this to this, Deep Space One. Its secret is a new kind of engine, the ion drive, and it's the passion of NASA scientist Mark Raman.
The idea for ion propulsion's been around since long before I was born. But the first time I ever heard of it was in a Star Trek episode. They're using ion propulsion. And Spock says, configuration unidentified, ion propulsion, high velocity, unique technology. And I thought, well, this is really amazing, but I'm never going to see anything like that in my lifetime.
But in 1998, Mark Raymond's dream became reality. Deep Space One. But what is it that makes the ion drive so different? Compare it with the conventional rocket. The rocket fuel burns with tremendous force, and as it thrusts down, it pushes the rocket up. In the laboratory, Mark Raymond watches a prototype ion drive in action. Instead of tons of rocket fuel, the engine uses a few grams of a gas. It gives the gas an electric charge and spits it out atom by atom at incredible speeds, creating a seemingly gentle blue haze. The ion drive doesn't have the raw power of a rocket. It has something better, staying power. It's a bit like the hare and the tortoise. Conventional rocket engines create huge thrust and awesome acceleration. But they burn through their entire fuel supply in just a few minutes. After that, it's all over. The ion drive is nowhere near as powerful. In fact, it would take Deep Space One 4 days to get from 0 to 60. But the reason Deep Space One is the fastest spacecraft ever is because it's been accelerating for almost 2 years.
When we communicate with that spacecraft out so far in the solar system, to think that our baby is out there, this little spacecraft that we built, I think it's really amazing.
Ion Drive spacecraft will be fast enough to chase down comets or travel around the planets of our solar system in just a few months. But even ion drives don't last forever. Eventually, they too will run out of fuel. To travel further, to reach the stars, we'll need something new. And it may be based on one of the oldest technologies we know, the sail. Long ago, the limitless power of the wind carried our ancestors to new worlds. In the future, we may use the same idea to travel to the stars. On sails that catch nothing more than sunlight. A solar sail, using only the light from our sun. Many scientists are sure that this is the future of space travel. One of them is Les Johnson.
the sun puts out photons, light. Standing here on a sailboat, the photons that are falling on us are pushing on us. But the push is so slight that we don't feel it. All the other forces around us are so much higher in magnitude that it's not noticeable. But in the vacuum of space, if you have a large enough, light enough material, the pressure that's exerted from these solar photons can cause that to move.
To see if sunlight could provide enough force to drive a sail through space, Johnson and his team built this, a man-made sun.
In front of me, we have a simulated sun about 3 times brighter than what the sun is at the Earth, and that's the reason I'm wearing these UV protecting sunglasses, and that it could damage your eyes if I were to accidentally look right into the beam.
They're testing the ultra-thin, ultra-lightweight material they would need to make a real solar sail. It's mounted on a rod in the full glare of their artificial sun.
As you look in there, you can see it slowly rocking back and forth. What's causing that is a sunlight pressure, the photon pressure, as it's pushing on the sail.
Incredibly, it works. This piece of sail material is being moved by nothing more than light.
Based on work that's being performed around the country, solar sail technology is getting to the point where very soon we'll be flying it in space.
To reach the immense speeds needed to travel from star to star, the solar sail must start its voyage with as big a push as possible. It must fly as close as it can to the source of its power, the sun. It's a dangerous maneuver, but if it works, the craft will whip around the sun and hurtle out into space at almost 3/4 of a million kilometers an hour. A solar sail could reach the nearest stars in just decades. It's a truly impressive start, but is it enough?
Our galaxy is a very big place. To get from one side to the other, even using a super-fast solar sail traveling at incredible speeds, would still take 2.5 million years. And our galaxy is only one of billions that make up our universe. This is the final frontier. If we ever want to be true star travelers, we're going to have to take a completely different approach. We're going to have to learn how to manipulate the very fabric of space itself.
Some scientists believe there may be a quicker way to get around the universe. One of them is cosmologist Peter Coles.
When early man first began to explore his environment, he would run into fundamental barriers whenever he came across mountains. The mountains are not easy to cross. When you're faced with a wall like these mountains around us, you've got no choice either but to go around them or over the top. Now these days it's exactly the same thing with space travel. If we're going to explore and colonize our galaxy, then the distances we have to travel are truly immense. So when it comes to space travel, we're really still very much in the Stone Age.
The answer could be to take a shortcut. Don't go round the obstacle, go through it.
If you travel through space, you're fundamentally limited by the speed of light. But it's just possible that the laws of physics might have a kind of loophole in them which allows us to travel slower than the speed of light, but still travel huge distances in a very short time. And the way you can accomplish that is through a wormhole. A wormhole is basically a tunnel that takes a shortcut through space-time. Say here to the nearest star could be connected by a very short tunnel.
Wormholes may sound like science fiction, but creating one may just be possible. First, we'd have to harness the incredible forces of an exploding star and use them to punch a hole through space. We'd need exotic forms of energy to keep the tunnel open. But the science is sound. At least in theory, it is possible to create a tunnel that reaches clear across the universe. Experiments have already begun to try and build the first tiny wormholes.
In theory, wormholes would take you from one side of the universe to the other in literally no time at all. Instant travel anywhere. A wormhole could just as easily have taken me halfway across our galaxy. But with the universe at your feet, how do you decide where to go? For that, you're going to need a map.
Space, as we've discovered, is very big. But Professor Brian Boyle and a team of Australian astronomers may have the beginnings of an answer. They're creating the biggest map imaginable, a map of our universe.
Traditionally, astronomers had looked at the universe as a flat map on the plane of the night sky. You can think of it like a map of the Earth. For a hiker, a flat map, it's no use at all. A flat map wouldn't tell you if there was a mountain in the way or a huge ravine. In the same way, the hikers of the future will need a three-dimensional map to guide them around.
To create a three-dimensional map, Boyle and his team had to develop a unique piece of equipment. 10 years in the making and weighing over 3 tons, the device uses over 600 fiber optic cameras. The whole apparatus is delicately maneuvered into position high up on one of the biggest telescopes in the world.
Everything's connected up, we're ready to go. Fibers in position. What we're going to do now is to take the telescope back up to the top and wait for the stars to come out.
Every night, the telescope looks at a new patch of the night sky. And for each point of light it sees, a robot places a single fiber optic camera. The light from the object is measured and its distance from the Earth accurately calculated. So far, the tireless robot has looked at and logged the positions of tens of thousands of stars and galaxies. Bit by bit, it has pieced together an unequaled picture of the universe. And this is the result. For the first time ever, we can see what our universe looks like in 3 dimensions.
When the map was first created, I was really filled with a sense of mixture of awe and excitement. Here I could see, almost developing in front of my own eyes, was the structure of the universe. Giant archipelagos of galaxies stretching hundreds of millions of light years across intergalactic space.
The day before I'm going to launch from out here, I go to the beach, right over there. I go to the ocean. I lie in the ocean and I look at the satellites crossing overhead, but I look at those satellites just whizzing along, and I think, tomorrow that's me. So I think on that kind of thing where you don't know if you're coming back and you don't know the final outcome and you may not really know where you're going to end up, you focus on a journey and that's what carries you forward.
There's a lot out there to explore, and one day humanity may be lucky enough to do it. Our children or our children's children will reach for the stars. So the next time you look at the night sky, remember that space is stranger and more beautiful than we can begin to imagine.
And above all, remember this. Out there in space is our future.